All right, so we looked at the sample spaces and the counting principle and tree diagrams and all that stuff. So these can then be used in calculating probabilities. So we're going to have two different types of probability. We're going to have theoretical probability and empirical probability. Now, usually when people say probability, they think in terms of theoretical probability. So theoretical probability, when you have a sample space where all of the outcomes are equally likely, so like for example tossing a die or flipping a coin, those are instances where all of the outcomes are equally likely. The simple probability of any event is going to be the number of favorable outcomes in that event over the total number of outcomes in the sample space. All right, and remember we had talked about probability always being between 0 and 1. Well, that just makes sense then, because the number of favorable outcomes can never be greater than the number of total outcomes, right? So that's why it can't be any greater than 1. All right. What's the probability of rolling an even number when you roll a six-sided die? So this is one that I had referenced actually before. So an even number in this case is going to be your event E. So E is going to have which outcomes in it, right? It's going to have all the even number outcomes in it, which are 2, 4, and 6. And the sample space, which I'll call S in this case, from rolling a six-sided die, remember we had said was 1, 2, 3, 4, 5, 6. So there's 6 outcomes in the sample space, and there's 3 favorable outcomes. So in this case, the probability of this event E is going to be those 3 out of the total of 6. Or, so you can write it as a half, or as 0.5, or as 50%. You can always write it in any of the 3 forms: fraction, decimal, or percent form. All right, so that was the probability of an even number. So what's the probability of rolling a number greater than 5? So in the case of a number greater than 5, now my E, my event, would actually just have the one outcome in it, right? The outcome in E now is only 6, because it's not greater than or equal to 5, it's actually just greater than 5. So in this case, the probability of the event is going to be just that one single outcome over the total number of outcomes, which we did above, which was 6. So that was 1/6. And then the other type of common experiment that you see here is when you're choosing a card from a standard deck of 52 cards, and there's your deck of 52 cards. You can see what you have is you have half of them are red, half of them are black, because there's 4 suits, not suites, that's actually should be suits, there should be no E in there: clubs, hearts, spades, and diamonds. And what happens is the clubs and spades are the black suits, and the hearts and the diamonds are the red suits. If you pick a card from this deck, what's the probability of getting a king? Well, there's actually 4 kings, right? And there's 52 total cards. So the probability of getting a king, and I can write K for king, is going to be the 4 kings out of the 52 total cards. The probability of getting a spade, well, a spade is that symbol there. That suit is known as the spade. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cards in that suit. So the probability of a spade is going to be 13 out of 52. Now the Queen of Hearts is actually a specific card. The Queen of Hearts is actually this one specific card here. So there's only one favorable outcome there. So the probability of the Queen of Hearts is just that one card out of the 52 total. And then the probability that it's not a diamond, well, a diamond again is one of those suits. So there's 13 cards that are diamonds. So if there's 13 cards that are diamonds, that leaves 13, 13, and 13. So 39 cards that are not diamonds. So the probability of not getting a diamond is actually going to be 39 out of 52. Right? So that's pretty simple, especially when you have the picture of the deck of cards there for you. Now, so those were all theoretical probabilities. So now empirical probability is actually what you observe when an experiment is actually carried out. So if you actually do an experiment and you get specific results, that's going to be what you call empirical probability. So they give you a nice little distinction between the two down on the bottom here. They say theoretical probability is what should happen, right, in theory, and the empirical probability is actually what does happen. So theoretical is should happen, Empirical is what does happen. So that's a nice distinction there between the two. And then the last thing here is kind of a nice thing to think about, what's called the law of large numbers. It basically tells you that if you do an experiment many times, what eventually happens is the empirical probability will get closer to the theoretical probability. So let's say, for example, I flip the coin 100 times. I'm probably going to get pretty close to 50 heads and 50 tails, but if I only flipped it, let's say, 6 times, it's possible that I could get 6 heads, or it's possible that I could get 6 tails. But the more times you do the experiment, the closer that the results should be to the theoretical probability in general, right? And we can actually do this. We have a little website that simulates this for us. So let's say I only toss the coin 10 times. So I got 6 heads and 4 tails. So when I did 10 flips, 6 heads, 4 tails. So the empirical probability of heads was 60%. But now let's say I do 20 flips. Now I got 8 heads and 12 tails. So this is actually 8 out of 20 is actually 40%. Now let's say I do 50 tosses. If I do 50 tosses, I got 26 and 24. And 26 out of 50 is going to be 52%. And then let's say I do 1,000 tosses. I got 509 and 491. So 509 is going to be 50.9%. So you can see it here, right? I mean, this is just a small example of it, but here it's working because the greater number of times I flipped, the closer that my empirical probability came to my theoretical probability, right? Because my theoretical probability would be 50% heads, 50% tails. So as I went down, right, with more flips, I got closer to 50%. So that's illustrating the law of large numbers.